Okay, so I'm going to do one of these problems from 9.3, 9.4. People seem to be having problems on this last set, and understandably so. They have like three tables here, and it's only the first table that you need to use. So I'm not sure why they stuck the two extra tables here. So let's take a look. Maintaining your balance may get harder as you grow older. A study was conducted to see how steady the elderly are on their feet. They had the 40 subjects stand on a forced platform and have them react to a noise. The forced platform then measured how much they swayed forward and backward, and the data are in the table below. Do the data show that the elderly sway more than the mean forward sway of younger people, which is 18.125? Now, let's notice that we want to know, do they sway more than the mean, which is 18.125. So more than will be greater than. So as we get ready to think of all our alternate hypothesis, the correct parameter is it said mean, so we want the mean, so we want mu. And what is the wording of the parameter in the context? It is measuring the mean sway of these elderly people. So let's see if we can find the mean forward sway for all elderly people. Now realize that when we talk about a parameter, we're talking about everyone in the group, um, not just the sample. So mean forward sway of all elderly people. All right, now our alternate, we said greater than, more than. So let's go ahead and write that first, and then we'll go back to the null here since we sort of just talked about that first. Where is mean? There it is. So we want that the mean is greater than. Now we might need to change that to greater than or equal to here in a minute. We'll see what we've got as alternatives for. And let's see, what was that number for the younger people? 18.125. Okay. Now our alternate, like I said, we might have to change that to greater than or equal to, but I don't think so. Let's see what our choices are. So we'll say is, in general, our null hypothesis will always be equal. So that's what we're going to say, equal to 18.125. All right, now assumptions. Since we're talking about a mean, let's see, quantitative data was collected, that did numerical, and we see that in our table. What conditions do we need to check? Now, anything that involves p or p hat does not involve our means, so we can ignore all this stuff that has these p's and p hats in them. That does not apply. But we do need, for the mean, we need a sample size that's greater than 30 or a normal population. All right, so we definitely need that. Um, if we're assuming normal, we don't want outliers in the data. And let's see, I don't think we had our standard deviation. Let's see, did it tell us? It did not tell us the population standard deviation. So the population standard deviation is unknown. Now, once we've chosen those, it asks us to check those assumptions. Is the value of this population standard deviation known? No, we said it was not. Are there any outliers? No. Um, and we haven't talked about the normal probability plot. Um, but we have talked about box plots, and we could do a box plot, and we could say no, the box plot shows no outliers. Now, it's not necessary. We can kind of look at this data and say, well, that's fairly, oops, this first box is, these are all fairly close together. The only thing that might be an outlier is that 7 because it's kind of far away from the first other set of data, but probably not too far away. So for the moment, we're just going to say no. Um, and of course, um, unless it's a long way away. Go ahead and say that at this point. Now, our number in the sample was 40? Yes, 40 subjects. So N, go back down here, was 40, which is greater than or equal to 30. Okay, which of course that's what we need. We need it to be more than 30. Is it reasonable to assume the population is normally distributed? Um, well, we don't necessarily, oops, I'm looking at the wrong. Let's see, do we have that it's normally distributed? We do not, but we do know as we check this drop-down menu that it's not necessary since the sample size is at least 30. So we don't know if it's normal, but remember that if we have a sample size greater than 30, then our sampling distribution becomes approximately normal. So this is okay. So let's see, name the test. The conditions are met to use a t-test since we don't have the population standard deviation. Okay, and the symbol and value of the random variable on this problem are as follows. We know that we're going to be finding a mean, but as we do our test statistic, it is a sample mean. Let me find it. I guess that's the sample mean they've got there. It looks almost like a hat instead of a bar. All right, and our sample mean for us, we need to get that from the data. So here's where you may have tried this and had a little bit of problem. Oh, well, I didn't do very well there. Let me try. I only want this first box right to there, and that's kind of misleading. Like I said, I don't know why they stuck these two boxes in here because it tends to um, cause problems. So I'm just going to put all of this into Excel. Let's see, there were 40 of them. So I want to make my box at least that long. And then I'll just hit my clipboard, hit paste, and there they are. Okay, so let's do equal average, open it, and then I'm going to highlight all of these data and make sure I get them all. Okay, and you'll notice that it shows them all in there, and that is 28.25. Now, while I'm at it, while I'm still here, let's get the standard deviation for the sample as well. And I'm going to do exactly the same thing, just highlight all that data. And close it. And there's our standard deviation. All right, so 28.25. Let's go back. Right here, okay, to this is going to be 28.25. Now, the confusing part of this next part is all of these blanks are really just asking us to fill the formula in for the t statistic. And these questions are sort of giving themselves away back from what we had up here just because we see that t statistic written there. All right, so we need x bar, which is 28.25. That goes in the first blank, minus our mean from the hypothesis test, which was 18.125. And then we need our standard deviation, which let me look back at what it was. Oh, wrong one. Right here. 8.8045. Let me, I could probably paste it, but just in case, I'm just going to write it down because sometimes pasting things into my open math just doesn't work. All right, so 8.804865, and I believe our sample size was 40. Indeed. Okay. So this is 40. And we're going to have to figure this out now. All right, so I'm going to go ahead and put these pieces into my calculator. Now I get 7.27282, and it says to round the final answer to 2 decimal places. So we're going to round this to 7.27. All right, now obtain the p-value. And it's probably going to be very, very tiny since 7.27 is a great many standard deviations above the mean. So, but let us remember that when we look up 7.27, we are going to get the area to the left of it, and we have to subtract it from 1. Now, we're probably going to get 0.9999999 when we do that, but we'll find out here. Now, we're going to put 7.27 in, and we need our degrees of freedom. So we had 40 in our sample size. 40 minus 1 is 39. So our degrees of freedom are 39. So I'm going to go back here, type in E equal T dot dist 7.27. Degrees of freedom are 39, and then the word true. And it tells me 1. Okay, so it's really 0.99999, but so close to 1 that it has just rounded it up. So I said that we have to subtract it from 1 because our alternate hypothesis was a greater than. And anytime we have an alternate that's greater than, whatever we get out of Excel, we've got to subtract from 1. So really, we're going to put in 0 or 0.0000. It's so small that it really doesn't register. Now, it really isn't 0. It's some tiny, tiny, tiny decimal. But since we're rounding to 4 decimal places, it's going to end up being 0. So let me go back. And let's just put in the p-value as 0.0000. And notice that it's possible rounded that p-value is 0.000. All right, now that p-value is incredibly small, and it is certainly, let's go back up here. We were testing it at the 0.05 level, so it's certainly smaller than 0.05, which means it falls in the rejection region, and we are going to reject our null hypothesis. So since the p-value is less than 0.05, we reject the null hypothesis. Let's see, we reject our null hypothesis. So there is significant evidence. There is significant evidence to conclude all elderly people, let's see, the mean forward sway of all elderly people is greater than, is more than, there we go, is more than, let's see, what was our null, 18 something, 18.125? 18.125. All right, so there's significant evidence to say that the alternate is true since we have rejected the null. And there it is. And hopefully that will help you through these long questions.